All right, so our next adventure in Unit 4 for 930 with our exponents is we are going to talk about negative exponents. So if you've noticed so far with all of our exponent properties, we've had positive exponents, or we learned what happens when the exponent is a 0 back before the quiz. So now we're going to throw into the mix, what about if one of those numbers up there in that exponent spot is a negative number? So that's what 4.4 is all about. Now, this can get a little bit tricky and it can get complicated when you put everything together. So we're going to spend 2 days really focusing on these negative exponents to try and ease you into it a little bit. Okay, so just as a warm-up, let's just remember back to some of our other exponent properties. Pause your videos now and see if you can do these too. All right, so hopefully you remember your exponent properties about dividing like bases. Remember, when we're dividing like bases, we subtract the exponents, right? So, so far in this unit, we talked about always doing the bigger minus the smaller. So in this one, I would say, 12 minus 5 equals 7, right? So I would have x to the 7th would be left, and I put my answer where the bigger exponent was. So this would become 1 over x to the 7th. That's how we've done it so far. And so if that's how you answered that warm-up, perfect. You got it. That's right. Over here on number 2, you could say, all right, well, same idea, right? Dividing like bases, both are a's here, right? So I do 5 minus 3, which gives me 2. So I have a to the 2nd is left. And where's my larger exponent? Down here at the bottom. So this would be 1 over a to the 2nd. Now, the reason I had you do these as a warm-up is because, we do the subtracting, we did the bigger minus smaller, but what if I just did top minus bottom, right? What if I just did 5 minus 12 over here on the first one? 5 minus 12 is negative 7. So that would say that my answer would be x to the negative 7th power. But that's the same problem. So that means that these two things are equal. X to the negative 7th power is the same as 1 over x to the 7th power. So that negative exponent is kind of like telling us that it's the reciprocal, right? That negative exponent on a regular base just tells us, hey, this needs to be on the bottom of the fraction, because you can think of it like a subtraction problem, or a division problem, right? Where I'm subtracting my exponents of like bases, but the bigger number was on the bottom. That's what a negative exponent is all about. You can kind of get that idea over here on number 2 as well. Same thing, right? If I actually did top minus bottom on this one, this would be 3 minus 5, which gives me negative 2. So my answer here would be a to the negative 2nd power, and that has to be the same as 1 over a to the 2nd. So that's how you can just start to get an idea of what a negative exponent is all about. So if I really narrow it down then, so in this one, we just did a to the negative 2nd in our warm-up, right? So we just learned that that really means 1 over a to the 2nd. So that negative exponent is telling me to move that base down to the bottom. And notice when I move it down to the bottom of the fraction, my exponent has now become positive. No more negative exponents. Number 2, what happens if I have that x to the negative 6th down at the bottom to start with? Well, when it was really, in the first one, it's kind of like on the top of the fraction, right? It can be over 1 if you want to. So on the top one, this was really on the top of the fraction, and it moved down to the bottom. Well, on the second one, it's at the bottom already. So if I think reciprocal, well, that would move it up to the top, right? So this would become x to the 6th over 1, right? Or it's moving to the top. Or you can just write that as x to the 6th if you want to. Okay, so if you have a base with a negative exponent, if it's on the top of the fraction already, and remember when there is no fraction, it's on the top, then it moves to the bottom. You think reciprocal, right? It moves to the bottom, you flip it upside down. If it's already on the bottom, you think reciprocal, okay, flip it upside down, so that means it's going to move up to the top. So on number 3 here, I have x to the negative 5th on the top. I have y to the negative 3rd on the bottom. each of those bases has a negative exponent. So that means I'm going to take this top one and I'm going to move it to the bottom. I'm going to take the bottom one and I'm going to move it up to the top. So it's going to become y to the third on the top and x to the fifth on the bottom. And notice again, whenever I move that base, that exponent becomes positive. So our shortcut here, whenever I see a negative exponent tells me to move the base, right? That means bottom to top, top to bottom, top to bottom, or bottom to top, depending on where it started, okay? Move the base, and then after you've moved the base, then the exponent becomes positive. Because if you kept it as a negative exponent, you'd be moving forever. Move, 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 move. Endless loop, right? So you want to make sure that once you move it, the exponent becomes positive. No more negative exponents going on. So now that we're throwing negative exponents into the mix, your answer is never finished. You're never completely simplified until all of your negative exponents are gone. If you still have a negative exponent in there, you can move it wherever it needs to go, top, bottom, and then your answer will have all positive exponents. So answers should always have only positive exponents. You're not done until they're all positive. Okay, so the shortcut is to move the base. You can also think of that as, kind of like reciprocal. That's the idea, right? And that's going to come into play here on our bottom two. It's the negative power of a quotient. So what happens if I have a negative exponent outside of parentheses like this, right? Well, if you really think about what this means, remember we know our power of a quotient idea is that we can take that exponent and give it to each of the bases inside the parentheses, right? As long as there's multiplying or dividing inside, then I can just distribute the exponent here. All right, so that becomes x to the negative second over y to the negative second. But both of them have negative exponents. So the y to the negative second is going to move to the top. X to the negative second is going to move to the bottom, right? So this is going to become y to the second over x to the second. Okay. Now, that's if we followed our old rules and then did the negative exponent rules. Like that can work. You can definitely do it that way. The other way to think about this one, though, is if you have this negative exponent of a fraction, I know that a negative exponent is really going to flip it, right? Or you can think reciprocal. So you could flip the whole thing first and then distribute your exponent. Okay, so this is what I mean. So I'm going to just kind of work over here. So x over y to the negative second. And I'm going to think reciprocal here. Flip. So what that means is I'm going to become y over x. Notice I flipped it upside down. And now I just have a second power. So this is a little tricky, and if this is confusing for you, go back to the old way like we showed at the beginning. Distribute your exponent and then worry about the negatives if you have them. But sometimes it'll save you a little time, and if you're really understanding that concept of a negative exponent, then this is a shortcut for you. And then we can just say, all right, I flipped the fraction because it was a negative exponent, so reciprocal, right? And then distribute after that. So it becomes y squared over x squared, which is exactly the same thing we got the other way. So if I use that idea on number 5 here, that idea that I'm going to say, oh, interesting, okay, let's do the reciprocal here. And if I do that first, that would become b to the third over 2a. So I flip it first, and now my exponent is a positive 3. And then after I have that, now I can distribute to everything inside, right? So this can become b to the 9th, 2 to the 3rd, a to the 3rd. So it's all your regular exponent properties. It's just whether you want to, distribute your negative exponent and then move things around, or if you want to see that, okay, maybe I have a negative exponent, so I could just do that reciprocal, turn my exponent positive, and then distribute only positive numbers. So you have two different options here, but I'm not quite done on this one because I do have a numerical base. So my final answer here is going to be, where am I going to go? I'll squeeze into here. B to the 9th over 8, a to the 3rd. Okay. So our shortcut for a negative power of a quotient is that you can do the reciprocal, or in other words, flip, right? First, and then distribute. That's definitely an option. Or you can distribute and then move after that based on whatever negative exponents you have. So when you have a negative exponent outside parentheses, you have some options. But just remember, a negative exponent means move the base, top to bottom or bottom to top, okay? All right, let's practice a little bit. So again, like I kind of mentioned earlier, now that we have negative exponents involved, you're not finished. Your answer is not completely done until you have only positive exponents. So if you look at what you're saying is finished and there's still a negative exponent involved, you're not done. One more step. Move it where it needs to go and turn it positive. Okay, remember also that you should only have each variable once, right? And there shouldn't be the same base listed twice. That means you could combine some exponents. There's no powers of a power, and all fractions are in simplest form. Okay, so let's try it out here a little bit. So here's number 1, 3x to the negative 5th power. So I see a negative 5th power there, right? So I know that I'm going to be moving something. Now be careful. This is very similar to our 0 exponent ones. What exactly has a negative 5 as the exponent? The base of that exponent is the x. It is x to the negative 5th power, but only the x. What's the invisible exponent on the 3? The invisible exponent on the 3 is a positive 1. Right? So right now, all of this is on the top of the fraction because there was no fraction existing. So only the base of x is going to move down to the bottom. So the 3 is going to stay put right up here at the top. It's staying because it has a positive 1 as an exponent. Only negative exponents move. But that base of x is going to move down to the bottom, and it's going to become x to the positive 5th power down at the bottom. So my answer is 3 over x to the 5th power. So just be careful, right? Be really careful on what base actually has that negative exponent. And only negative exponents move. All right, here we go. Number 2, negative 4x to the negative 6th power. So again, what is raised to the negative 6th power here? The x is to the negative 6th power. The negative 4 has an exponent of positive 1. Now be careful, right? Negative 4 is the base. Negative 4 is not an exponent. Negative numbers don't make something move. Only negative exponents make something move. So this is very similar to the last one in the fact that this negative 4 is going to stay put right up there at the top. That's just a negative number, not a negative exponent. But the x to the negative 6th has to move down to the bottom. So it's going to become x to the 6th down at the bottom. No more negative exponent. So my final answer here is negative 4 over x to the 6th. Again, negative 4 is a base. It's a coefficient. It's not an exponent. Negative numbers don't move. Only negative exponents move. All right, number 3 is an interesting one. 2 to the negative 6th times 2 to the 2nd. There are 2 different ways to do this problem. Pause your video and see if you can come up with one of the 2 ways. All right, so I'm not sure about you, but if you have your old exponent properties in your brain right now, then the first thing that pops into your brain is probably, hey, these are like bases. I'm going to add my exponents. So negative 6 plus 2, right, becomes 2 to the negative 4th power. Now we just learned today that something to the negative exponent means to move it, right? This is all on the top of the fraction right now. So this is going to move down to the bottom. So it's going to become 1 over 2 to the 4th, right? Or you can think reciprocal, right? 2 to the negative 4th, reciprocal, 1 over 2 to the 4th, if you like thinking reciprocal instead of move. All right, and then I just have to simplify this numerical base, so this becomes 1 over 16, right? 2 to the 4th is 16. That was the one way to do it, and that's a good way. I kind of like it. But you could do this a second way. So I'm just recapping the problem here. Same problem. So if you had negative exponents in your brain, you were maybe thinking, well, I see this negative 6, 2 to the negative 6 power. I should probably move that down to the bottom of the fraction, right? It's technically on the top. So your first step could have been leave the 2 to the second where it is, move the 2 to the 6th down to the bottom. So it becomes 2 to the second over 2 to the 6th. Now, on these problems, think of the entire problem as one fraction. Don't make it 1 over 2 to the 6th times 2 to the second. It's gonna just mess up with your brain, right? So always think of the entire problem as one fraction. So if you want to move something to the bottom, then everything else is going to stay on the top of the fraction, and that will move to the bottom of a single fraction. Okay, now I can say, wait a second, now I'm dividing like bases, right? When I'm dividing like bases, I'm going to do bigger minus smaller. So I'm going to do 6 minus 2 equals 4, and the bigger exponent is down here at the bottom. So I will have 1 over 2 to the 4th power. And look at this. I'm right back in the same place. 1 over 2 to the 4th is 1 over 16. So you can do those either way, and we kind of talked about that back before the quiz, right? Exponent properties are cool and tricky like that you could do them in any order that you want, but your work is going to look a lot different depending on which order you do it. So you could combine like bases first and then move, or you can move first and then combine like bases, whatever makes sense to you. All right, let's try some more here. Oops. All right, so here we have w to the 6th over w to the negative 16th. So they are like bases, but rather than attempting to subtract with negatives, I will always move my negative exponents first before doing any subtracting, because the odds that you're going to get all those negatives right, especially if you're just trying to do mental math, are very slim. So in this case, I would say, that the w to the 6th is going to stay put, right? The w to the 6th has all positive exponents. Sorry, w to the 6th is a positive exponent, so it stays put right there. Then w to the 16th is going to come up to the same level. So both of them now are on the top of the fraction, and there's nothing left down at the bottom. So I don't really have to write the over 1 if I don't want to, but I just wrote it so you can really picture that it's all up on the top, right? Well, now w to the 6th and w to the 16th, those are on the same level. So I'm just going to combine those, and here I'm going to add my exponents, right? So that would give me w to the 22nd. So now if you think about it, if you just subtracted right away, you'd have to really watch those negatives. 6 minus negative 16, which would give you w to the 22nd, but the odds you're going to get those negatives right are very slim. So I highly recommend that you move your negative exponents before you start trying to add or subtract when you're dealing with the ones in a fraction like that. So you practice number 5 now. Go for it. All right, so again, the x to the negative 2nd is going to move to the top, but the x to the 5th is going to stay put. So x to the 5th stays there. X to the 7th moves up to the top with it. Nothing left down at the bottom. Now they're on the same level, so this will become x to the 12th on the top, but you don't have to write the over 1 anymore. All right, number 6, 3 over x to the negative 7th, excuse me. Now again, be careful. What is the exponent on the 3? The exponent on the 3, is that invisible 1, but it's a positive 1. So that 3 is not moving. It's going to stay put. The x to the negative 7th, though, that needs to move up to the top with it. So this 3 is going to stay on the top of the fraction, and then the x to the 7th is going to move right up there with it, and there's not going to be anything left on the bottom. So we could just write our answer as 3x to the 7th. Very common mistake, though, is to flip the whole thing. You want to say it becomes x to the 7th over 3, just flip the whole thing upside down, but that 3 does not have a negative exponent, so it needs to stay up on the top of the fraction. All right, last 3 here, just to make sure you're really feeling confident. Number 7, x to the negative 11th over y to the negative 6th. Notice the x has a negative exponent, so it's going to move down to the bottom. The y has a negative exponent, so it's going to move up to the top. So once I move them, I will have y to the 6th up on the top of the fraction. Notice my exponent turned positive. And I will have x to the 11th down at the bottom of the fraction. Again, exponent turned positive. Okay. Number 8, 15w to the 9th over 5w to the negative 4th. More going on in this one now, right? I have a fraction, so be careful. Coefficients operate differently than our variables with our, like our exponents. So the first thing I see here is that I have my coefficients of 15 over 5. These are coefficients. I'm going to divide, right? If I just covered up the rest of the problem and it just said 15 over 5, that means 15 divided by 5. Right? All right, so I'm going to really think about that. So 15 divided by 5 is going to give me 3, or 3 over 1, or the bigger number was on the top, so my 3 is going to be on the top of that fraction, right? Then I see, okay, I have a w to the negative 4th, so that needs to come up to the top as well. But the w to the 9th does not have a negative exponent, so it's going to stay put right there. But the w to the 4th is going to come up to the top with it. And there's nothing left on the bottom. So this looked like it was going to be a fraction, but there's nothing left on the bottom. So my final step here then is now I have 2 like bases on the top. So I'm going to multiply like bases. So that means I'm going to add those exponents. So I'll end up with 3w to the 13th as my final answer. Nothing on the bottom, so I don't have to write the over 1. All right, number 9, kind of similar. See if you can do that one on your own. All right, so here again, coefficients, 8 over 2. Those are coefficients, regular numbers. I'm going to divide those, right? Then I see that I have n to the negative 4th. That's got to move down to the bottom. But my n to the 6th doesn't have a negative exponent, so it's going to stay put. So if I'm thinking about where everything is going to be, let's see, 8 divided by 2 is 4. 4 over 1. 8 was on the top, so my answer of 4 is going to go on the top here, right? My n to the 6th wasn't moving, no negative exponent down there, so it stays down at the bottom. But my n to the 4th is going to move down with it, right? N to the negative 4th on the top moves down to the bottom. Now I have my 2 like bases down at the bottom of my fraction, so I'm going to add those exponents. So my final answer will say 4 over n to the 10th. 4 over n to the 10th on that one. Okay, hopefully you're starting to get the hang of those negative exponents. You're feeling a little more confident. Again, we're going to spend 2 days on it, so get your feet wet today, and then we'll kind of make them more complicated tomorrow. So just remember, all of your exponent rules apply, but now that we have negative exponents involved, the only thing that you're adding into the mix is whenever you have a negative exponent, move that top to bottom or bottom to top, okay? And don't forget about those exponents to the 0 power, although they won't show up too much today, but they're always a possibility. All right, good luck.